Differential calculus. Differential comes from the word differentiation, which actually means the process of finding the derivative. Derivative means gradient, guys. Change. And we are going to be calculating that change. And when we calculate that change, we call that calculus. So the term calculus, let's simply call it calculating. So putting these two terms together, what we are going to see at the center of differential calculus is calculating the derivative. So let's first go through some topics. So what we can expect in calculus questions are 4 categories of questions. The first one is the derivative by first principles. We're going to be calculating the gradient of a given graph using a formula that we call first principles. So that formula goes like derivative. This is the symbol for derivative. Let's say the graph is f. The derivative we write f prime x. Let's say the given graph is g. The derivative is going to be g prime x. If the given graph is h, the derivative is going to be h prime x. Nazo. So when we use the first principles to find the derivative, they usually call it graph f. And the derivatives formula is going to be f prime x is equal to limit as h approaches 0. So the limit of f of x plus h minus f of x all over h. And by the way, we don't have to memorize this formula. This formula is going to be provided for on your formula page. So this is the first question we're going to come across in calculus. Derivative by first principles. Second one, derivative by differentiation rules. That's going to be the second topic. We will get there. Number 3, cubic function and also other functions in calculus. So right here in calculus, we're going to do a graph that looks like this or that looks like that. And it's going to be what we call a cubic function. And how is it related to calculus? Remember, calculus has to do with calculating change, which we call the derivative. So a graph can change direction by going up, down, down, up. Other graphs, other functions can be a parabola, smiley face or sad face, even a straight line, increasing function and decreasing function, because they have gradients. So we are also going to be coming across these other functions besides cubic functions. The last question we'll come across will be the application of calculus. Remember, the word differential has to do with the derivative, which means change. And change happens in everyday situations. So that's going to be the practical application of calculus, which is the last question that is set by the examiner under differential calculus. Here we go. The first topic under differential calculus is about finding the derivative using the first principles. When we do maths questions, it's always a good idea to know how to start, how to continue the question, and how to finish the question. So when we do first principles questions, this is the process. Step 1. Now for step 1, guys, we need to check what this formula consists of. Right here, we have f of x plus h. That's what we will find first in step 1. So hang in there. We're going to be demonstrating this using past exam questions. That's step 1. So this is how to start. After finding f of x plus h, in step 2, we already have f of x, which will be given. So all we need to calculate before we can use this formula is f of x plus h in step 1. F of x is already going to be there. So in step 2, we are going to be substituting what we have into this first principles formula. So we substitute. And step 3. In step 3, we are just going to simplify until h approaches 0. So how to start, how to continue, and how to finish the question. All right, this is the first question, which is so excited to meet us. We are finding the derivative by the first principles. This is the first principles formula. F of x is equal to negative x squared. In our step 1, we are going to be finding f of x plus h. So you will notice that on the left-hand side here, in the original equation, we have x in brackets. But f of x plus h has x plus h in brackets. What that means is what they did on the left, we must also do on the right side. So on the right hand side where we see x, we are going to be putting x plus h. Let's do it. In the place of x, we are writing x plus h. Not forgetting to square it because the x is squared on the right hand side. After that, we remove the brackets by multiplying. Let's work out the square part first, leaving the negative outside the brackets. So x squared, then we multiply everything we see. 2 times x times h, that will be 2xh. Then we square the h, getting h squared. Close brackets. After that, we multiply completely, multiplying everything inside the brackets with this negative sign, which is actually a -1. So negative times x squared, negative x squared. Negative times 2xh, negative 2xh. Negative times h squared, negative h squared. We just got ourselves f of x plus h. Now, step 2, we are going to be substituting what we got into the first principles formula. Let me write it down. Nazo, by the way, guys, we get 5 marks just to do first principles. That's something, huh? So we continue writing limit h approaches 0. And in the place of this f of x plus h, we are going to write what we got up there. Negative x squared minus 2xh minus h squared. That's our f of x plus h. After that, we have this minus, followed by f of x, which is actually our original function. Here we go up there. We have f of x, which is negative x squared. So in the place of fx, we just write negative x squared. Substitute it in brackets because it's not just x squared. We have a negative all over h. Then we continue with all the patience we can have. We write limit h approaching 0. This is all worth it, guys, for 5 marks. We are now in step 3 where we are simplifying. So the top part there, we have some brackets. So we repeat everything. When we get to the brackets, we just multiply. So negative and negative, that's positive x squared all over h. Now again, we continue to write limit h approaching 0. We simplify. Remember, in maths, after removing the brackets, it's always a good idea to check whether we have the like terms. Like terms may add up or just cancel out. So in this case, negative x squared is cancelling out positive x squared. We have left negative 2xh minus h squared all over h. Now, here's the heart of this process, guys. Remember, when we say h approaches 0, we are going to be imagining in the place of h having 0. But up to so far, the only term on the denominator is h. And if we put 0 in the place of h, we are going to get undefined because anything divided by 0 is undefined. Which is why in the next step, we're going to have to get rid of this h from the denominator. How do we do that? We factorize. So we factor out h as a common factor, but we still continue to write limit as h approaches 0. We take out h as the common factor, h only because h is our target here. H into, so in the first term here, we took out h, we are left with negative 2x. Second term, h squared, we took out h, we are left with 1h all over h. After that, we cancel out h with h, and we are left with limit h approaching 0. We are left with negative 2x minus h. It's time to conclude now, and this is what we do. We don't necessarily substitute 0 into h, guys, because we are saying h is approaching 0. So we are just imagining if h had to be 0. So in the place of h here, if there is 0, what do we have left? We are left with negative 2x as our final answer. And checkmate. Next customer, please. Question 2. F of x is equal to x squared minus 3. 5 marks, the same process. How to start, how to continue, and how to finish. How do we start? We start by finding f of x plus h. So we write f of x plus h. And what that means is in the place of x, we are going to be putting x plus h. Where there is x, we write x plus h, not forgetting to square because the x is squared, minus 3. Then we remove the brackets by multiplying. We square the x first. That's x squared. We multiply everything we see. 2 times x times h. That's 2xh. Then we square the h, getting h squared. Minus 3. Any like terms? Not really. What do we have? F of x plus h. The first principles formula. So we're going to be substituting what we have, which is f of x plus h, into the first principles formula. So we start by writing limit as h approaches 0. Where there is f of x plus h, we substitute what we got up there. That's x squared plus 2xh plus h squared minus 3. In the formula, what comes next is minus, then fx, which is our original function up there, x squared minus 3. So in brackets, we substitute x squared minus 3 all over h. So we're winning already. We keep writing limit as h approaches 0. Now remember, we keep writing limit h approaches 0 until h is no longer part of the denominator that can make everything undefined. Then we drop the limit in our final answer. All right, let's simplify what we have so far. We see some brackets at the numerator there. We're going to remove them by multiplication. X squared plus 2xh plus h squared minus 3, negative times x squared, negative x squared, negative times negative 3, positive 3, all over h. We keep going, limit h approaching 0. As we simplify here, we notice that x squared, it's positive, negative x squared, they will cancel each other. And also, negative 3 is cancelling out positive 3. What do we have left? 2xh plus h squared, all over h. Let's write that down. Starting with limit as h approaches 0. At the numerator, we are left with 2xh plus h squared. Divide all that by h. Then limit as h approaches 0. We are almost there, guys. The only thing is that we cannot make h approach 0 if we only have h at the denominator, as the only term at the denominator is going to make everything undefined. Why? Anything divided by 0 is undefined. So this is the time to factorize h so that h will cancel h in the next step. So in this step, we are taking out h as the common factor. H is the common factor in the first term and the second term. So in the first term, we took out h, we are left with 2x. Next term, that's h squared. We take out h, we are left with just 1h out of h squared, all over h. Now, so h outside the brackets will cancel out h at the denominator. Then limit h approaching 0. In brackets there, we are left with 2x plus h. Now it is safe to say in the place of h, we imagine 0. And what do we have left? We are left with 2x. We drop the limit. Our final answer, we are just going to write 2x. And checkmate. Next customer, please. Now this one, guys, has a fraction. Finding the derivative by first principles. We are given fx is equal to 1 over x. You might want to give it a try. Pause the video, give it a try, then continue watching. How do we start? We start by finding f of x plus h. So we write f of x plus h. Where we see x on the right hand side, we put x plus h. Now, so then step 2, we are going to substitute what we got into the first principles formula. In the place of f of x plus h, we are going to be putting what we got up here. So we write limit h approaching 0. F of x plus h now is 1 over x plus h. After that, in the formula, we have minus f of x. And f of x is our original function up there, which is 1 over x. All over h. Then we continue to write limit as h approaches 0. Now you will notice that we have so many fractions going on here. So it's going to be a good idea to change the main division line into multiplication sign. So the top fractions here will remain together, but this longer division line is going to become multiplication sign. So the top will just be like this. Then we say times. At the bottom here, we have h. Remember in maths, after we change the division line into multiplication sign, we switch. So h is the same as h over 1. We are going to make it 1 over h. Then we write limit as h approaches 0. Now watch this. Here we have this fraction right here, subtracting this other fraction. And how do we subtract a fraction in maths? We use the LCD technique. Watch on the left here. The LCD method of adding fractions will tell you that if we have a over b plus or minus c over d, we simply multiply the denominators. In this case, that's b times d. That's our lowest common denominator. Then we cross multiply to get the numerators. A will multiply D to get AD, plus or minus depending on the question. B will multiply C to get BC, the LCD technique. Back to our question. In the same way, we are going to multiply our denominators. So this X will multiply X plus H. So we are getting X times, in brackets, X plus H. That's our LCD, lowest common denominator. After the LCD, we cross multiply to get the numerators. After the LCD, we cross multiply to get the numerators. So 1 will multiply X, we are getting X. Minus 1 will multiply X plus H. So that's 1. Watch this, guys, because this is a place where mistakes happen. Remember, this one is multiplying 2 terms. So we use the brackets. So that's X plus H. So this one is multiplying 2 things that are coming as one term. So we put everything in brackets. Times 1 over H. That's not changing. The next step, we still start by saying limit H approaching 0. Then we simplify the numerator. We see the brackets, we're going to remove them by multiplication. So we have X first, then negative 1 times X in the brackets, giving us negative X. Negative 1 times H there in brackets, giving us negative H. All over. We also multiply here because our final answer is not supposed to contain any brackets. X and X, that's X squared. X times H, that's XH. Times 1 over H. Almost there, almost there. This is equal to, again, limit H approaching 0. As we simplify further, we see that X is cancelling out negative X. What do we have left up there? We are left with negative H all over X squared plus XH. Times 1 over H. If you watched until this far, guys, you might wanna like and subscribe. It will help the channel. Thank you, thank you, thank you. Next step, limit H approaching 0. So this time, guys, there is no need to factorize because why? Since we are multiplying 2 terms here, this H up here is cancelling out the H at the denominator. At the numerator, we are left with negative and 1. So we write negative 1 all over X squared plus XH. Now it's time to drop the limit because why? We imagine H approaching 0. So the H term at the denominator, imagine it as 0. You don't literally put the 0 there. We just imagine it as 0. So that's going to cancel out. And we are left with negative 1 up here. At the denominator, we are left with X squared. So the final answer is negative 1 over X squared. And checkmate. See you in the next video, guys, where we are going to be doing rules of differentiation.